Okay, so this is the 2023 paper 2 question 9 on your differentiation application style questions. So they tell you that the diagram shows a rough level road, right? Shaded, bordered by a straight level road BXA. So this is the level road, and this is the rough area, or the shaded area is your rough level road. Okay, they tell you point C is on the rough ground and B is on the road closest to C. So B is on the road closest to C. The distance AB is 15 km and the distance BC is 8 km. A cross-country runner is at point A, right? And on the road, and he needs to get to point C as quickly as possible. The runner can maintain a speed of 5 km per hour on the road, right? But only 3 km per hour on the rough ground. So on the level road, it's 5 km per hour, but on the rough ground, it's 3 km per hour. Okay, the runner realizes that in order to minimize the total time to get to point C, it is necessary to leave the road at some point X, right, between A and B. So over here, right, is where he leaves the road, and he runs directly from point X to point C. Okay, let AX be the distance X km and T be the total time in hours taken to be for the runner to get from point A to point X. Okay, and then from point X to point C. Right, so now we need to show that the total time that he took is equals to this. So total time that he took is quite straightforward, right? Because on the road over here from AX, right, we can see that the total time is time for AX plus time for XC. Okay, so the time for AX is quite straightforward because we have a distance, we have a speed. So immediately from our DST, right, to calculate time, right, we use distance divided by speed, which our distance is just x divided by speed. For total time for XC, we need to first find the distance of XC over the speed of XC, which in this case the speed of X3 is just 3. So all we need to really find is the distance of XC if you just directly compare with this. So distance of XC over here, you can see that actually this is just a right angle triangle, right? And actually BX is something we can find, right? BX is actually just 15 minus X. Okay. Right, because you need to know this so that you are able to utilize your Pythagoras theorem to help you find your XC, right? So for XC, it is using a Pythagoras theorem, right? So XC squared is the same as X squared plus 15 minus 8 squared. And because we are interested in finding just XC, we will square root this whole thing, in which here you need to know that you need to expand because we need to get to that expression. So in here, 8 squared is 64. In here we get plus 225 minus 30x minus x squared. Okay, let's use your rainbow. Simplify this. We get it to be, sorry, this is plus x squared. Get it to be x squared minus 30x plus 289, and that's our XC. We just sub this back into here. So our total time is just x over 5 plus root x squared minus 30x plus 289 over 3 shown. Okay, should be quite straightforward for this part. For part B, they tell you find the expression of dt over dx and show that this value of x, which the time taken is a minimum, satisfies this equation. Okay, so let's first find our dt dx. Right, so from above, we have our time to actually just be 1 over 5x plus 1 over 3, this whole square root thing. This square root thing, I'm going to convert it into to the power of half. Right, then I'm just going to differentiate with respect to this because it's easier that way. So we differentiate this, right? Differentiate x, you just get it to be 1. So we get it to be 1 over 5 plus 1 over 3. Bring down the power minus 1 differentiate the inside. Right, differentiate the inside, we get it to be 2x minus 30. After you get this, we simplify the whole thing. Okay, this becomes 1 over 6 multiplied by 2x minus 30. So actually it's just 2x minus 30 over 6 times x squared minus 30x plus 289 power. Okay, and then they tell you that for which the time is taken to be a minimum. When it's taken to be a minimum, it suggests to you that your t dx actually equals to 0, because it's your stationary point. This is stationary point. So you just equate this to 0, right? And we will find that we can just simplify this whole equation. Right? I'm just going to move the 1 over 5 over, so it becomes negative 1 over 5. Then I'm going to multiply, I'm going to cross multiply. So I'm going to multiply the negative 5 up, right? And I'm just going to multiply this very complicated one up to the 1. Right? So this side becomes just negative 10x minus 150. Sorry, minus becomes plus, because negative 30 times negative 5 is equals to 6 times x squared minus 30x plus 289 power half. Okay, here we're going to square both sides because we want to get rid of the square root, right? So by squaring both sides, okay, this becomes okay, I'm just going to write it out first. Negative 10, 150. Right, this becomes 36 x squared minus 30x plus 289, and that's all. Okay, this thing on the left gives you 100x squared minus 3000 x, right? Cos minus 150, sorry, 1500 minus 1500. Okay, and the last one is plus 22500. I'm just going to expand this 36 in. (36 times 289) 10404. Okay, after this, we're going to shift all our terms to the same side. I'm going to shift everything to the left side, right? So 100 minus 36 gives us 64. Then 3000, negative 3000 plus 1080, 1920. And the last one, 22500 minus 10404. 12096 equals to 0. And all we need to do here is just to simplify. We divide everything by 64. Right? We get this to be 189. 1920 divided by 64. We get it to be negative 30x. And this just gets us x squared. And just like that, we will have shown. Okay, so that's how you do part B. And lastly, for part C, hence find the minimum time taken, right, which is just basically solving this equation, right, in which but after we solve this, we are only getting x, and remember x is a distance from your point A to point X, right? So that's a distance. We still need to find the time from there. So let's first solve for x. Right, in which you just use a quadratic formula, negative 3189 x minus 21 x minus 9 equals to 0. X either equals to 21 or x equals to 9. In this case, we will need to reject x equals to 21 because x is less than 15. So this is Rejected. Reason, x is less than 15. Okay, once we have the time, right, all we need to do is to sub this time into our time equation from part 1, because we already found it in terms of time, right, in which our time equation is just our x over 5 plus our square root of this whole thing, x squared minus 30x plus 289 over 3. Right, so we just sub all our values in. 9 over 5, 1 minus 30 times 9, 270x plus 289 over 3. Right, press this whole chunk in your calculator. Oh, sorry, there's no x here anymore, my bad. There's a minus 270 plus 289. Right, you will get this to be 2 over 15. Right, and this is also the same as when you multiply 2 over 15 by 60. This is in hours. It's the same as 8 minutes. So total time, 5 hours, 8 minutes. This is your final answer. Okay, so this is how you do the 2023 paper 2, question 9. Not as straightforward, but definitely doable, just using Pythagoras theorem for the first part, as well as a bit of your DST relationship. Second part is just differentiating and then simplifying. And then the last part is just solving and substituting the value. Okay, so that's all for this paper.